So far, everything looks relatively straightforward. We prepare a parameter for function strlen, then we push parameter on the stack where strlen is supposed to find it. Let's try to build this. And as you can see, I'm getting error that tells me that the strlen symbol is undefined. Of course, in the C program, we always find the correct header to include. But here, perhaps because this symbol, of course, is not defined by our program, the technique actually is to use extern directive to say that this symbol is a near symbol, means in our flat memory model it's just all symbols are near symbols, don't require combination of segment selector registers and addresses. Everything is readily available, and because this is a procedure part of C standard library, all we need to do is just essentially tell the assembler, don't worry about this, the linker will be able to find these symbols somewhere in C runtime library. So we're going to build this again. So this time assembler passes without a problem. However, the linker complains about strlen reference in function main right here, and that it tells us that it's still unresolved external symbol. Well, Microsoft has resources on their website, specifically one of these links right here. Let's try to bring this up. And it talks about C runtime library features, and it explains to us that starting with Visual Studio 2015, the entire library was relocated into the binary files, and it tells us basically right here how you can use this inside Visual Studio. And the lib files are actually for the linker .lib files that they specify here, and it's absolutely great news that we can include library files directly in the assembly module. So if you want to include the entire C runtime library, basically like all includes that exist for the C library, this is what you need to do. You can just include these 4 lib files, and you pretty much will be all set to program anything you like, as if all the includes were already resolved in your assembly file. I will give you a little bit more information here. There's also Stack Overflow website that you can check to read a little bit more about this. More information well explained on Stack Overflow, why and how these files can be used, and some examples using them as well. So with these new includes, okay, we should be able to now go to, in fact, I think that what's important is that I'm going to move these options to the top. They should always appear at the top of our assembly module, because we need to tell assembly module what kind of memory model we're using. Everything else is validated against this type of memory model, so it has to happen, I believe, has to happen at the top. So with this in mind, let's try this again. And one more thing is left, is that we have to specify that we're not using any sort of exception handlers in our runtime library. Otherwise, the linker gets confused about the kind of libraries that we're trying to compile this entire executable into. So let's go to project settings, and actually in 2 places, Microsoft Macro Assembler Advanced, we need to say that we're not using safe exception handlers, so the answer here is no, right? Microsoft Macro Assembler Advanced, use safe exception handlers, no. And make sure that you set this for all configuration. And also in the linker section, same thing in the advanced section. If you scroll all the way down, make sure that you select all configurations to make this update, and there are different options, so we're just going to say no to all of the options, right? So just say no, that we're not using any kind of safe exception handlers. This makes an impact on what gets compiled, actually what gets linked by the linker into the final executable result. So I'm going to click apply, and what I have changed is, again, linker, advanced. At the bottom of this list in my project settings, image has safe exception handlers. No, we don't have any of this. And likewise in Microsoft Macro Assembler part, also advanced, use safe exception handlers. No. All right, so I'm just going to click OK now. We're also going to tell the linker that we are using a standard calling convention, which makes a difference in the way that the parameters are passed, and also the way the names are decorated. So let's use standard call, which is basically pretty much all system functions are using this type of calling convention. In our case, it really makes no difference. It's really just making sure that the linker understands what we're trying to build here with all the library modules. So let's just clean everything and save all of our files and rebuild. Okay, so now we have everything built, and so this is the result so far, that we are able to build this. And now we're calling strlen, which, by the way, should return a result in register EAX. By the way, you can see it in from our C example, that after calling strlen, we take EAX and store it in strlen. So strlen gets its value after the call from the register EAX, which was populated by this function right here. So in our case, of course, we should make a comment that the result is in EAX. So we know that strlen will return the length of our string in register EAX. There is also one more important part that is demonstrated when we look at the disassembly of this C++ code, that we also maintain stack. So we definitely need to do this, because the calling convention that C standard library is using is called C calling convention, is that the caller has to remove arguments from the stack. Right here we placed the address of our source string on the stack, because we populated register EX with this offset and we pushed it on the stack like this. But now we have to remove it from the stack. So we're just going to make some stack maintenance by adding 4 bytes to register ESP. Because when we say push, I'll just draw this again one more time, a quick demonstration. So this is our stack. Okay, and we have register ESP, which is always pointing to the top of the stack. Right here we say push EAX, and the content of register EAX is copied right here into the stack. And now ESP is pointing to the top of the stack. Then we call strlen, which does its thing and returns back value in register EAX. And then we really have to maintain stack. At this stage, ESP is pointing to this location on the stack, ready for the next value to be pushed. However, we want to eliminate the results of the push that we made before calling strlen. It's our responsibility when working with C runtime library. So we're going to add 4 bytes, because EAX is 4 bytes in size, right? So EAX is 4 bytes. So we need to kind of remove it from here and do it and and change the value of stack register to point back to where it was right at the beginning. And for this we add ESP4 because the stack is growing in the direction of lower addresses. So these addresses here are low and these addresses over here are high. Okay, so these are high addresses, and when we want to maintain stack and get rid of something we placed on the stack, we must add something to the value of ESP to remove it, logically remove this element from the stack. So this is why we have to do this, and we can add a call, an explanation that C library does not remove args from the stack. We have to do this manually, and this is manually, right? And so this is what we're doing by doing maintenance right here. So the important outcome so far is that now we have register EAX that contains the length of the string that we're trying to use as a source for copying it to our destination.